showed you before, it's a queue structure. It's using, if you go back to the data structure class, so you learned about the linked list as the first, probably first one. It's pointer next data structure, next data, next data. Basically, so we don't have to keep all the PCB next to each other. Instead, there's somewhere in your memory here and there, you can delete. So it's actually use such a process information using the pointer. Okay. We will see more details. So it's a process schedule. The CPU scheduling is one of the most important part of the operating system for better performance. Because anyway, we need to share the resource. How? That is the algorithm of the scheduling. Okay? And we discussed about the context switch. Here the change A to B. So information data in the register for A are different from the B. Right? So whenever we change the process, we need to copy all the information about the A to the PCB and bring the PCB for B to the CPU. So this is called the context switch. So it's a kind of the dilemma. The more context switch you have, it's fair, right? So like I opened the 1 hour the advisor time. So I have 100 students. So if I do not change the student, so all my advising hour, the office hour used for the 1 student. Okay, then the other 99 students will complain. So to be fair, so I quickly change my office hour, like the 30 seconds. Every 30 seconds, next student. But student should in and out. I should look up the student information. It takes longer time for transition. So optimization is important. What is the best way? So the more context switch you have, it's a waste of your resource. So the less, it's unfair. So we need to consider such a thing during the CPU scheduling also. So when we consider the mobile operating system, mobile device, the most important part is the resource. That is the energy, the battery power. So to say, in terms of technology, it's not a problem. But the problem is the physical, the power. So to consider such a limitation, we cannot put all the process on the foreground active. Instead, we are the early version of the mobile operating system only allow one process. That's the foreground. But we now we can use the mobile device, iOS or the Android, the multitasking, but still it's limited. So because of the energy consumption. Then finally, we discussed about the process creation. So this slide shows everything. What about the other operating system? I never been used. You didn't probably use such a process creation, the method. But behind you always, whenever you are clicking, double click or run your program, it's automatically. So this process is the system library has been used. So first, to create the process. So who create the process? The process. Who create the process? The current process. Yes. Current processor. That will be parent processor. So as so this is the first process, whatever that. Sometimes it's a Cont process, sometimes it's an init process, sometimes it's a SCHED, schedule demand the process, but there is always the first process. Then this process is the only one who can process. But how can we create the first process?
The bootloader.
Yes, that's what we discussed. So BIOS is the very simple operating system. It checks the input and output. So it's embedded. It's reside on the EPROM or any wrong type, which means you do not lose the data without the power. Okay, so you keep that the BIOS program know where is the first program, which is kernel. Then firstly copy into the memory. Then firstly create the process. So that is the first process, init process. Okay, then this process create the child process, and the process create another child process, so on. When you are using your application is always the last one. Okay? Then, for example, if you are using shell program or terminal or the command line or the desktop, it's always the last one. Then when you start your application program, it's the child of this process. At that time, this kind of program is called shell programming or desktop programming. Okay? So because of that, so most of people who are using computer are familiar with this, but not this. Nowadays, even GUI is much more popular and easy to use, so you know how to use this. But what about the shell? So shell is also important. That is the reason I emphasize on in this operating system class to use this. Okay, then how can we create such a process? The only way is we should use system library. So we are going to use the system library. So check the operating system, what system library the supported to create the process. So we have learned there are two types, the API system library. One is the POSIX for Linux and Unix. Another one is the Win32. Java is a little bit different. So set aside. It's hard to say the Java is the system library, even though this textbook mentioned regard the Java is one of the system library. It's a little bit hard. I mentioned several times, but we will see the later also. But you can say the two of them. POSIX also has the system library to create the process, that is the fork. And another one is EXEC. There are two system libraries. So the difference is fork actually create new process. However, new process does not mean, so I'd like to learn the MS Word. But it's not MS Word yet. It's just allocate the resource. Because allocating resource is the most important part of the operating system. Without resource, you cannot make your children. Okay. First, you need to make the space, room, and bed, and something to eat. Everything should be ready. Resource. So, fork actually search then allocate such a resource. That means it's create the new process. Okay. Once you are ready such a room and resource, then EXEC is copy the specific programming code, like the word.exec. This is the program. So number of sequence of instruction code. This one will be loaded into where? The allocated memory. So two step. Why we have two step? If we cannot find the location, it should be error, right? First, you need to check because we have a very limited resource. If we have unlimited resource, we don't have to worry about the fork. Just copy. But since we have a very limited resource on the memory, so first find the resource. That is a fork. That means it's a creating process. Then, if okay, that means we are ready. Then copy this one to the allocated memory. So it's always two-step, two system library, fork and EXEC. However, Windows, they still complain. Always fork and EXEC is paired. Why not combine into one? So Win32 has a create process Win32 API. So it's a combine the fork and EXEC. So it's a C or C++. This one is Win32. What about the Python? I'm using Python. I never used the 4.6 API, but Python library supports such a fork and exec. It's the same. Basically, this is the Python code that called this one, system library. So some of the program languages support such a thing, the others are not. Like the Java is different. Java is one process is the JRE. Okay? And inside, if you create the process, that's not process, that's later we will talk about thread. So we need to know what is the process, what is the thread difference. Next class. Okay. So then we will see a little bit more detail. What happened when we call the fork and exec. So again, yes. So fork first in your parent process. So here we can it's really annoying because okay. So we have the parent process here. So parent process first run the fork system library. Then operating system take over. You remember the dual mode. So dual mode, the kernel mode, operating system find the resource on the memory. So if you can find the 32K, for example, the memory, then allocate it and return the process ID, because process ID is most important, the data structure, like the social security number. When you have a newborn baby, social security number, like that. So PID will be returned there, which means it's already created a process. In other words, allocate the resource. Then it's not done yet. Then parent also run exec to copy the program, specific program. Then is being loaded into the memory. Then so your child process is running like that. This one. Okay. Then at that time, what happened? Parent process.
It depends.
It depends, but most of the case,
It waits.
wait. So parent is waiting until the child process is done. But some of the operating system allow to do something. Or even if you are using the Unix or Linux, you can actually avoid that, which means you can run the child process at the same time parent process. If you run this one with ampersand as a background, which means this one is a foreground. This one is running and this one is running. But actually, first time when we developed such the system, we are using the waiting for the child process.
After the fork, they are separate. After the fork,
Yes or no?
yes. Or
We will see. Why is it yes or no? Okay, it's not entirely separate.
not entirely separate.
Yeah. So we will see. So, but you should remember the parent is waiting for the end of termination of the child. Then when the child is terminated and the parent is waiting.
Wait.
So this is another system call. The parent, after fork and exec, the parent run the exec, which means wait for the exit of or termination of the child process. Then take over, then going forward. Like that is. Okay? This is a general mechanism of the creating process in most of the operating system. Okay, then we will see what is a really independent or not. Then next. Yes. So this is an illustration of the what happened when you run the fork and exec on the memory, from the memory point of view. So, let me pause. So here, actually, this is the illustration purpose. This one should be like this. So, lower memory and higher memory. And this part is the current process. It's a parent process over here. Then, when you run the fork, okay, find the resource. So you find the resource like this. But at that time, code, what is the code? It's the programming. So, parent run the ls command. So we are going to create a new process for the ls. Okay? This one should supposed to be ls, but after fork, it doesn't have the specific code. It's here, the code part. It's not independent yet. It has the memory, so this part is the child. This one is the parent. But code part is actually point the parent, which means it's identical. Parent and child are same, exactly same. It's identical. You understand? So, the parent process is the bash shell. So this one is a bash. Okay? This is a processor for parent. After fork, so operating system find the memory resource over here for child, for ls. Okay? ls. So you find. However, still this is not for ls, this is the bash. It's just a copy. Okay? Copy of parent. Exactly same, identical. It's not independent yet. However, you find the memory resource. So you are ready. What about the code part? Text part. It point the parent. You don't have to copy because eventually you are going to upload the ls, the program. So when you run the exec, then this part is actually point the bash. Then after exec, you don't need this. Instead, you are going to load the programming for ls. Then it's independent, separate. Still, it's not fully independent because it's a child and parent. Parent is waiting. This one, wait for what? The return of the child when exit or terminate. Why? The parent is waiting.
Because the child processes using resources.
Yeah, resource. Resource management is most important, but once this is done, the parent should be in charge of free this one. And then receive, I'm going to do my way, and free up this resource inform to the operating system. Then operating system, we don't need this one, this is done, and this is the current process later. So that is the fork and exec. So during the fork, so many students are confused. Why do we need the two-step always, fork and exec? So if you understand that this the process from the resource management, the point of view, resource management. So first we need to find the available spot. That is a fork. If we find it's a return code, then assign the ID. So you can stay here. So you have the ID 10. Then once you got the ID, then bring your stuff. That is the exec. Then you can study. Once you are done, inform to me. Once you are done, inform to me. Then as a parent, then it's open to, it's free to other. You can create another process. Like, okay, so this is a fork and exec. Then it's always a two-step. Okay. What about the Win32 API? When you run the create process, the system library at once. First find inside actually basically two fork and exec. So they find the resource, then the upload the data part, programming code. So then eventually the process will be such a tree structure from the root process or the system. Sometimes it's INIT, sometimes it's swap, sometimes it's schedule, sometimes this one is a system D. It doesn't matter. Then it has the eventually mostly end user. So your application will be created by the shell or desktop. So desktop is a graphical user interface, the shell program, like that. Okay. So this is a really example of C program, how to use the fork. So let's see. So first part is the including header data structure for your library. Shared library will be linked based on this one. We are going to use the sys types the library, and as you know, even though you do not know the C, C++, you probably know the stdio. Any input output should be included. So stdio and then so on. So C also starts with the main function arrays, as you know. So main function then is a variable PID, because return of creating process fork is the process ID. What about the file? Whenever you create a file, so if you create a file, like the read, write, return code is a file ID. It's a FD, file descriptor. It's an ID. So actually operating system know only ID. File name is not important. Process name is not important. They don't care. So what they care is the ID. Process ID, file ID, and something ID. Even memory structure, if you create the message queue ID, or the pipe ID, only ID. Okay? This ID is managed by the file, like the PCB on the memory, like that. So then let's take a look at this one. I tried to use this, but not sure that I can. Yes, this time is better. So this one is the finally create the fork, right? So what happened this time? So we have this program. Let's say this is the what's the name? So A food CP create process.exe. Okay, this is the current process. So .exe is the parent process. So parent process is the PID equal fork, which means it create on the memory side. This is the memory side. This is the cp.exe on the memory. Then find the space. Then exactly same thing, but it's a new one. So this PID is 100, let's say. So this one is PID is 100. This is 100. Once you run the PID equal 4, what happened? This one is assigned new 101. And it's still cp.exe, exactly same code. Because the fork does not create the new instruction code. It's exactly same as the parent one. Then we need to check. There are two of them. They are running simultaneously. So PID is less than 0 means it's a fail to find the available space. So definitely it's an error. It's not a problem. So this code will not be run in case of the PID is not assigned, like the -1. So this means it's not allocated. Okay? So this one is error check. Then PID is equal to 0 means so cp.exe. There's a PID value. This process ID is 1 and PID value is 101. 1. the process ID of cp.exe, the parent, is 100. Then inside 100 process, if you run the fork, output of the fork is the new PID for child. So PID value is like this. Then this PID is 101. Then what about the PID value of the child process? 101? Well, 100? Well, what else?
102.
102? This is another process. This is the G.
Oh.
Right? Because it's not assigned, they never create the value. Because it's after fork. Okay? Why fork is a copy, but the PID itself, the child of the PID never run is 0. Because of that, you can recognize which one is the child, which one is the parent. Then this one is this part is the checking. Which one is child process? What about this? In case of parent process, it's a positive number. Child process is 101. So 101 case, we need to do what? Wait. Otherwise, it's keep going. So the parent should wait until child is done. Then child part, so this one is child, the PID 0. Then this part, their program code is exactly the same thing until this time. But you can run exec. Exec wrote ls. Then ls is where is it? It's the hard disk drive or somewhere in your shared memory or whatever. So you can load this one to the data part ls. Then run ls, the instruction, only for this. If you do not have this, what happened? Your parent process also run, right? ls. It's not child process. So then, after this one is done, ls, then what happened? Exit. When you exit, because the wait is waiting for exit, so it's an antenna. Like whether my child is back to home or not. Keep watching your child. Okay? Once your child is back, then give the dinner or prepare for the dinner. So wait for the end of this one. Once this child is terminate, then this one will be free, and the parent process is going to next. Okay? So this is the very simple general process, but you can create the process like that. Then somebody may be curious, why I need to check the child or parent of the parent process? Because during the fork, it copied the exact code. You need to consider what child process need to do in your parent code. Okay? So, we will change this one into your project one. So, it's time to talk about the project one. So, project one, you are going to create the shell program, UBOS shell program, whatever the name, you can decide the name. It's not like the bash shell or any shell. So, what is a shell? It's a command line interpreter. Mostly what? To run the process, to create the child process. So based on what? Command, like the ls, then ls will be created child. And output, yes. Then ps, command, yes, ps. Then keep going. This is based on REPL, right? Interpreter, line interpreter. So command line. So how can you make this one from this? While loop. You can just while loop until Control C. Same thing, while loop. Then the only problem is what? This. Right? So this one is hard coded ls command. but you are going to get the input. So you can just
Read from the.
yes, print and get the input from the user, right? So if type ls, just put this one, then keep running. So that is the first project. Very simple. If you understand the concept and you are familiar with the programming and also each library you are going to use, it takes 10 minutes to complete your project. But without understanding the data structure, you don't know what you are doing. Okay? So that is the difference. But the proof is too simple. Then there's another task. So project one has 2 parts. So second part I will explain later. Okay? The first part is based on this. This is a C program. So the problem is I'm not familiar with the C program. You can use the C. You can use definitely C++. You can use the Win32 API. So Win32 API for the C, Visual C, Visual C++, and I'm not sure .NET, so you need to check. So as long as you are able to use the Win32 API, it's any program language is fine. Then these are the core programs to use the system library directly. In other words, this is called the system program or Unix program, Windows system program. But I'm not familiar with any of them. So can I use the Python? Yes. So you can use Python in your project. Because Python provides a package for OS. They pretend the fork and exec. Even output of the fork is a PID. It's a mimic, the system library. So you are able to use it. If we are using Perl, Perl is a script language. Actually, Perl was developed by the administrator to make their job easy. So they developed a Perl. Perl also has this one. So one of the students already asked me, what about the Go program, Google Go program? Yes, Google Go also support such a system library. So any program language that support the system library, fork and exec also good, you can use. But at that time, please get the confirmation. What about Java? Java also you can pretend. But Java, actually, when you run the Java application, where is it running? It's inside the Java virtual machine. So in your memory, when you start the Java, it allocates the specific room for only Java application. This is called the Java virtual machine, JVM. Default size is 512 megabytes, the memory. Then, from operating system point of view, this is just one process. Then, when you run your Java application, inside the Java virtual machine, it creates a thread. So what is a thread? Thread is a light version of process. It's a pretend, it's kind of fake process. Because as you can see, the process needs a fork exec. It's a really heavy job. Because you need to find the room and the copy. So it takes a longer time. So thread is a light version of the process. Because mostly your child process is very similar as a parent, especially in Java, like that. So why not sharing some information? So for example, if you share some account, bank account with your parents, your life will be easy. But vice versa, your parents will use your account. So sharing always good? No, not always. Okay. So, but to reduce the job of the process, Java use the thread. So whenever you run or whatever, it's a thread. You cannot, from the operating system point of view, you don't know what happens. So that is the reason Java is not acceptable in this project. But the other program language, fine. So if you are not sure that none of this, please let me know. I can give the confirmation. Okay, so this is the project, and this is to clearly show how to. So creating process itself is a few lines of code. Really, it's not complicated one. Okay. Why I cannot see. Yes. Yes. Okay. So this is an example of the Windows. So you can. Windows, if you see this one, create process is the Win32 system library. Then this part, MS Paint.exe is the exe part. So your child programming code command. Then the others are the other argument. So it's basically a combination, combining the fork and exe. Okay. So there's a way. This is a way, so you can check whether if a process is not created, then the wait for child. If child process is the child complete. It's the same code as the C program, the previous one. Once you create this one, so you can check the process. So let me show you the example of the Mac. So this is the terminal that I'm using on netbook. So this one is, if you type the shell, so G shell is actually the same as the bash shell. So different name of the bash shell in Mac OS. So Apple guys, they like to use different name, but they are fully comparable. You can use the same command. So then, for example, if you want to see the process, so you can see all the process list, and they are yes. So for example, G shell login is the process ID here. Okay, then you can follow the parent 463 and 463 somewhere. So 463 is create the my login shell, and the my login shell. So this one G shell is a 27683. So 27863 is a parent, this is a child. So PS command and more command, two processes are running simultaneously using one. I have used the pipe. We will see what is a pipe also later. This is the most powerful feature of the command line comparing to the graphical user interface. So output of this one will be input of this, like the pipe. You can connect the two processes like that. So this is an example of the process in the Mac OS. I'm not sure I have the three command. So let me quickly check. It may take a time, so let's change it. Okay, so this is a process tree in the Unix. I'd like to show you this one, but I cannot. I didn't install that process. And this is the example of the Windows. Windows is also same thing. Windows has the different name of that. You can see idle system, then this one. Finally, your process is somewhere here, Explorer. Then you have this is the child process. Using the CMD, process this. Okay, so what happened when the child process is done? It's called the termination. Do you remember the process state? New and ready and running and wait and ready, running, eventually terminate. So when terminate is the inform to where? Parent. So parent is waiting for the exit signal from child. Once parent receive it, then the revoke all the resource. So that is the general the process. Then at that time, what happened? For example, parent is unfortunately killed. Parent died. Parent process died, killed. What happened? Child process.
It stays, right? Because it's a copy.
So
It's like a rogue process, like no one knows it's running because the parent died.
So, as we have seen the creating process, always child process rely on parent process. So, first time, when parent process is died, no reason, they cannot be survived. No parents means no resource. So, it will be killed automatically. So, that is called the cascading termination. Cascading termination is the popular. For example, I'm running program. At that time, my terminal is shut down suddenly, or something close my the terminal, and my application program is automatically gone.
Yeah.
That is the cascaded termination. But some of the operating system allow the child process is running, and also at this time. So this is the shell, G shell or bash shell. I'm running A.out program. It's really long, not A.out, like the Apache daemon. It's a web server.
Yes.
Okay, then the web server should running 24 hours and all the time, right? So what if I exit this one? This one will be what? Cascade termination, right? So how can we avoid this one? At that time, you can make the child process as daemon process. So daemon means daemon. What is the meaning of the daemon in dictionary? Ghost.
Oh, yes.
Yeah, right? Which means in operating system, daemon process means parent is no longer this one. Instead, parent is the init process. You can give the parentship to the, I cannot raise my children, please take care, the government. As the government, the daemon process, their parent process will be one, init process. Then, what happened? You log out. You can enjoy party, then your child will be taken care by the government. One, you can steal out. So this is called the daemon process. So you can make, when you run your child process, you can make the daemon process. Then, check your process list. You can see a lot of something D, like the HTTP D, Apache D, FTP D, and the file D. So these ending with the D process are daemon process. Their parents are 111, like that. So they will not be killed, even though parent is gone. That is daemon process. Okay. What about the zombie process? Zombie.
Zombie.
It's similar. Which one is better, daemon or zombie?
The term? I mean, it's from the demon term, so demon, I guess, would create its own parent, so it becomes like its own host. So I guess for zombie, it stays in the background regardless. So, you know, undead.
Yeah.
stays alive.
Think about the zombie, the movie. So zombie is it's not human, right? They are not, they're no longer human, but they are looks like pretending doing something. So zombie means in operating system. Actually, the operating system manage all the process. Whenever you fork, the process ID will be registered. This is the process list, process table or process list. So if there is a 101 process like the LS on the memory, it should be here. The process 101 process is a normal, right? Even though it's a daemon process, their parent is one, still like that. So, however, zombie process means it's on the list. It's on the list, but it's not in the resource.
What?
It's on the list, table list, process table. So government has the list of your name, but you no longer exist, really.
So how do you clear the?
Oh.
This is the zombie. So actually zombie process is not a big problem because
Yeah,
they are
it's
not
just
using,
resources.
yeah, they are not using resource. But you can see such a zombie process on your process list sometimes, accidentally. But most of the case, zombie process will be happen when you terminate your child process. So child process is done. Okay? So inform to parents, right? So at this time there is a resource in the memory is free.
Yes.
And from this point, operating system should remove the disk. It's a little bit time, right? 0.111 second, 0.001 second, right? It's not happen same time. First, the resource free, okay? Then take out the item from the process list. Little bit, tiny gap.
The child item. The child item.
Yes. So they have the ID, but it's not removed yet. Yes.
So it's basically like I open Zoom on the background, I kill Zoom, and before it
So
closes.
background is different.
Oh really?
Yeah. So zombie means no resource,
Oh.
but only in the table.
Okay.
That may happen every time actually, but it doesn't hurt.
Yeah.
So zombie, you don't have to worry about too much. Okay. The problem is open. Open. Sometimes you forgot or accidentally parent process do not wait, which means I'm done. So please release I'm done. Okay? So I'd like back to home, but you cannot back to home because there is no parent. So which means still memory is taken, but you cannot free up. This is called the open the process. It's an accident. So you need to take care. So sometimes defunct process is called the open process. How can you free up? You can forcibly kill the process by root superuser. Even superuser may not kill sometimes. That is taken. That is it used the resource. That is the problem. In case this is an infinity loop or something, bigger and bigger memory space you consume. So open zombie is not a big deal. It's always happen. So also, even though you see the zombie process on the process list, it's okay because that doesn't have any resource. But on the other hand, open keep the resource. Okay, so you need to do something like kill the process forcefully or something. Daemon process is totally fine. Okay, it's a normal process. Then what is the background and foreground process? So background and foreground process means that your parent dash create the ls. So wait. Okay? But during that time until the terminate, you cannot do anything. Right? At that time you can make this one, you run the ls command with ampersand. Means This one is keep running, but this one also foreground. Okay, you run. This one is a background running, background process. This one is a foreground. You can do your job. But once this one is done, then inform two. Then this one will be done. You can always change it, foreground and background, using FG and BG command. Okay? So you will practice during the exercise lab.
So Professor, let's say that because it happened to me, right? Like I have a machine running.
Mm-hmm.
I SSH to the machine.
Mm-hmm.
I put a server up in the background.
Mm-hmm.
I close my SSH connection and my server stopped running.
So, which means you run the long running job as a background. Okay? At that time you exit. Okay? This one is still running even though you exit, but once it is done, there's nothing to get. So it will be automatically terminated.
Oh.
But your output you should save as a file, like the redirection. Okay? Or in your program you need to save the file. That is the reason you can exit, but it's running. But once this one is done, it will be taken by your operating system. So that is the type of operating the process. Normal process, parent process, child process, daemon process, and zombie process, orphan process, and so. Okay, but it is based on the fork and EXC and such a creating process. Okay. So Android, for example, mobile operating system, they actually give the priority of the process. So from the foreground is what you are using to almost empty process, it's nothing. So because you can give the priority to the certain process, then you can save the resource, especially the display part. But sometimes you can, when you execute the one program, it creates the multiple child processes. They are working simultaneously. For example, Chrome. Actually, Chrome is notorious. They use a lot of memory because they create a number of the process. One is for browser, one is for the rendering, and one is for the, so for each, so when you check the processes, Chrome. So because one child, even though you start the Chrome.exe, that create another child process, they are working together. That is the process name, creating process and the process name. But our operating system, it's not like the simple document like ls, ps. They are simple, but sometimes we need to communicate. It's a network program, or sometimes like the Chrome, they need to work together. So several processes work together. So this is called the cooperative processes. It's very popular nowadays. You can use a thread later. That thread is different, so set aside. So several processes need to work together, which means they should be able to communicate each other. So in operating system, for such a communication inside the loop, okay, so they provide the inter-process communication. So it's called the IPC. So for such an inter-process communication, there are three types. So one is using shared memory. So shared memory means, so we have a bulletin board here. So if you are looking for your project partner, you can put here, note. So this is a shared board, bulletin board. So I need a project partner. Then if you are looking for the project partner, take out, then you guys can work together. This is a shared memory. So how can we implement in operating system? Operating system provides system library to create the shared memory on the memory. This is a memory, FFF, that you can create a certain area of the memory. So SHEM, MM like that. Basically based on the MRO, the system library, memory allocation. So you can use that area for the shared memory. So if you have the shared memory ID, from here, process 1, process 2, process 3, they write something and read something. Write something, read something. So this is based on the shared memory. Okay. Second, pipe. Finally, pipe. So for example, when I learn this PS minus EF more, do you remember I typed this kind of thing? PS minus EF, pipe more. Pipe means you can run two processes at the same time. One is a PS, another one is more. PS lists all the processes, but it's 100 processes. So it's a scroll up. So I want to control such a thing. More is the command. Screen by screen control, line by line control. So which means output of PS will be input of more. You don't have to save the output of this and read. Instead, we are not going to use this one. Directly communicate. How? At that time you can create the pipe on the memory. This is also memory structure. You can create a pipe using what?
System library.
Library. You can always search your operating system library. Then how to create a pipe. Probably output is pipe ID. In your program, you can read, you can write using the ID. There are different types of pipe. So always in and out, one direction. So somebody only put here. Then it's basically queue structure and read. Or bidirectional, to process the input, output, bidirectional. Okay? You learn the bidirectional linked list like that. You remember that? So you can easily implement such a thing. And also, this pipe can be anonymous. Everybody can use. Or sometimes you can name. Only two persons can use this pipe. There are different ways of using pipe. So this is the pipe symbol to use in your shell. So sometimes I change the scope of project. So sometimes I ask the student to implement the pipe. So you need to get the two input, you need to create the pipe and communicate. It's not very difficult. So this is a pipe. Third one, for the interprocess communication, is based on network programming, socket. So did you do the socket programming? What is a socket program? Client and server. So TCP/IP, if we are using TCP/IP, the protocol TCP and plus port number. Then you can create the channel, then you can do communication. Exactly the same thing you can use. Socket is more and more popular nowadays for the process code. Benefit, this one only for within one computer. Socket, it can be, as long as connected, you can use network. So my inter the computer.
It's like a hub.
Like the computer, you can through the network. So that is a socket. So three ways. But when we are saying the IPC, so mostly the shared memory and pipe. But this one is for network programming. Almost by my memory, the battery. Okay, so this is an illustration of the shared memory and the message passing. Message passing is the pipe. So you can create the shared memory, or you can create a message queue for the pipe. Okay. So this is basically based on the producer-consumer model. So producer generate the data and input the data. Consumer read the data. So this is basically the producer and consumer. So I'm going to quickly go over so you can actually do the such a IPC programming using system library. So let me show you the last comment.
Maybe.
So this is a command to show the or. Can you see the bottom? It's not so good. So IPCS is the command to show your the interprocess communication, the resource. So for example, the A is or, you can see the message queue and shared memory. Right now, I'm using one IPC shared memory, the resource. So I don't know what the application is creating this one, but anyway, it's a shared memory. Probably the operating system create this. Message queue is not. So if you firstly create using system library, so the message queue and shared live memory will be here. Okay, then you can monitor. Semaphore, we will discuss about the semaphore rate. Okay, during the synchronization. Okay, so you can see the list of the IPC. Then finally, you are able to create the process. You are able to run either communicate each other or among the processes. Then the last thing is the project. And there is a project over here. So this is the project one. So undergraduate student is both undergraduate and graduate student are required to complete the project one. So for graduate student, there will be another project, so project 2 later. So you need to select your own program language. Then what you're gonna do is you are going to create the shell program yourself. It's named the UBOS. So it's basically same as the other. So you can type anything, any command. How can you do that? You already seen the skeleton program. You are going to start with the skeleton program. It's a C, but you can easily find the other skeleton program in Python or others. Then what you're gonna do is you must use the system library, fork and exec for creating process and in terms of Win32 API. Then first, basically, it should be while loop because you need to keep receiving the command. That command will be input, like this one. While the printf, then the standard out will be the input of the then you can assign that the input command into the exe. Okay. Be careful. There are variation of the fork and exe. We fork and exec CRP. You need to check what is the purpose of the fork and something different fork and something different the exe. Find the purpose, the system library, and the usage. Okay. So part A is just creating the child process and running. Okay, so that is done. If that is done, the second part is that I'm going to explain later. Okay, so first, why don't you complete the due date is beginning of October. You have several. Why don't you check the due date, and you guys can start right now. Okay, any questions? Yes.
So my virtual machine doesn't work. I don't know why.
You mean the GCP?
Yeah. No, I mean the GCP works, but I can't get the viewer to work.
The VNC,
Yeah.
the connect. At that time, why don't you use the console? Then using the console SSH, you are able to connect. So that is optional. VNC client is optional. Probably it's a firewall setting. So you need to create the firewall rule to connect the GCP. Okay. Why don't you check it again, the firewall, the rule on GCP virtual machine. But still, meanwhile, you are able to connect your virtual machine using SSH, console SSH.
Yeah, 'cause I use that
Yeah.
because of the other one. Okay.
Then, let me check the other question. So assignment 2, the lab experiment. So this is the lab, it's not lab, this is a programming, the project. So, okay. I think that is the past. So thanks so much for your joining and thanks so much for your coming. So next week, the next class on Wednesday, please be ready for the virtual machine on GCP, and the GA, the BAMC will provide a recorded video, because I realized that doing the exercise, the live, is really complicated. So I'm going to use the recorded video for exercise lab. I will let you guys know after the Wednesday class how to get the link of it. Okay, thank you. We will see you on Wednesday.